Okay, hi, we're back again, and it is Wednesday, April 2nd, when it really isn't, but that's okay. This is when the lecture is. And today we're going to continue with Section 11.2 from your text on the derivative of exponential functions. We did a lot of examples, and now we'll do one practical example. I'm given that the revenue for a particular company who makes tents is 250x times the exponential to the 1 minus 0.01x power. I want to find the marginal revenue at x, the function, and then I want to find the marginal revenue when x equals 20 units. But if we look here, our definition of revenue is in thousands of dollars, and our definition of tenths is in thousands of tenths. So let's continue now and take the derivative. Now notice what you have here is two functions. You have here a regular function in x and an exponential function. So you have to use the product rule. And here I've put the product rule down here. U times dv dx plus v times du dx. I define u as 250x. and v as e to the 1 minus 0.01x. So let's take the derivative. Okay, u is 250x. And then I need the derivative of e to the 1 minus 0.01x. I'm going to add that to e to the 1 minus 0.01x times the derivative of 250x. So this is going to be 250. And usually I'm going to call this A because we're starting with it. This is going to be plus 250. The derivative of 250x is 250 times e to the 1 minus 0.01x. So let's work on A right now. And that is the derivative of e to the 1 minus 0.01x. And as usual, what we do is we make this to be e to the u, the derivative of e to the u, where u equals e to the 1 minus u equals 1 minus 0.01x, and du dx, it's hard writing as I get to the bottom of this board, is equal to minus 0.01. Now let's use the derivative formula. Excuse me, I have to erase. Sorry for my back. So the derivative formula, as we know, for a, I'll put it up here, dy dx is e to the u, du dx, that's the formula for an exponential. So in this case, d dx e to the u is going to be e to the u du dx, and we know this is going to be e to the 1 minus 0.01x, and du dx, of course, is minus 0.01. So we get here for a, we're still working on a here, is minus 0.01 e to the 1 minus 0.01x. Let's check my notes, make sure that I did this right. All right, now we're going to substitute back in, I'll call this equation 1, sorry. So we're going to substitute back in here. Substitute for A in equation 1. So let's write this over again. R prime X equals 250 times minus 0.01 E 1 minus 0.01x plus, right down here, 250 E 1 minus 0.01x. Now let me factor out. Notice, what can I factor here? Well, I can factor out what's common to both terms, 250 and E to the 1 minus 0.01x. And that's going to be what? That's going to leave you with what? It's going to leave you with, I think I'm missing something here. When I did this, let's see. Actually, not really, huh? Was there an x term here? Yes, wasn't it 250x?
250x, yeah.
Yes, okay, I am missing something. So this is going to be minus 0.01x plus 1, correct? The other way, I'm sorry. No, my minus 0.01x is right. Plus 1. All right, let me erase this here. We don't need this anymore. So what's next? Well, that's my, that's really my term, and I choose to leave it that way because I could distribute the 250 over here. It's actually easier to solve for part B in this form. So if you want, I could write this 250 times minus 0.01x plus 1 e to the 1 minus 0.01x. And then I could distribute the 250, but it turns out to be a lot easier to solve B because I want to find, when x equals 20, I want to find r prime 20. So that would be 250 times minus 0.01 times 20 plus 1 e to the 1 minus 0.01 times 20. What we're going to get here is 250 times 0.8 and this is going to be times 0.8. I'm sorry, that's going to be e to the 0.8. And when you solve all this, you get actually, I think 450. And that's dollars per tent. That's not unreasonable. Some of these big tents are $450. And that's your answer. Notice you put this right in your calculator, e raised to the 0.8. So that is, shows you how much. So what would the 20, what does this mean? This means that this is an approximate meaning, okay? Because I do get in trouble with the pure math guys for this. But that means that the 21st tent is expected to what? To have a revenue of $450. So the next tent is expected to generate $450 more to the company. And that's marginal. All right. So now what I'm going to do, I have finished 11.2, and I am going to give you a little quiz. Okay, I'm going to write the quiz down. And as with all quizzes, as I gave you today, basically, you have 3 days to hand it in. So today is the 2nd, you hand it in the 5th. So this is going to be quiz, and this is going to be our quiz number 4, since we had 2 before, but they were worth 2 quizzes. And this is going to be number 4 and 5, because they're worth 2. And the first one is going to be find dy dx if y equals 1/2 the natural log of x squared plus 3 squared plus 5x. Tell me when I have a minute left.
Mm-hmm. You have 4.
I have 4 minutes left?
Correct.
Okay. Okay. Next one is find dy dx if y equals 1 plus e to the 2x over e to the 3x. Okay. 3. Find the equation of the line tangent to the function below BELOW at the point 1 and y. Obviously you got to find y. So here is the function x e to the minus x. So find the line tangent to this function. 2 terms, product rule. And 4. And this is a big one. I have time for the next.
You have 2.5 minutes.
Oh, good. Okay, so at the end of an ad campaign, the sales function, sales of a product, is given by S of t equals 50,000 e raised to the minus 0.5t. Okay? Where ST is weekly sales, just in dollars.
1 minute.
Okay, and T is the time in weeks since the ad campaign ended. And we'll be back soon.